All right, the title for our lesson today is Sample Space. In your notes, set up your notes with the title Sample Space, and then the essential question for today is, how do I find the sample space of compound events? Hit pause and set up your notes with your table of contents, your title of your lesson, and then your title and your EQ on the next clean sheet of notebook paper. When you're ready to move on, hit play, hit pause to finish that up. Ways that we are going to represent the sample space for a compound event. Now, in our notebooks, we are going to do examples of each of these. You don't need to copy this one, but I do want you to write down the three different ways, just these words, the three different ways that we can represent a sample space for a compound event. This is going to be a bit more complicated than the sample space for simple events where we were just listing like heads or tails, or 1, 2, 3, 4, 5, 6, or the possible outcomes of rolling a number cube. Because here with compound events, we are having different combinations of the different steps of the action that are taking place. So for example, if I tossed 2 coins, I flipped a coin and then I flipped a second coin, I could use these 3 different ways to represent all the different combinations I could get. So here I see an organized list. We're going to make one of these for a separate example in a second. Here I see a table where I have the different options for the first part of the action. Here I have the different options for the second part of the action, and then I combine them in the table. And then a tree diagram, I have the first part of the action and then the second part of the action, and I do little branches. Okay, so make sure you have written down organized list, table, tree diagram, and then you're going to do these examples with me as I do them on the board. I need you to work them in your notebook so that you have an example of each. So here again we see, I just talked about this, heads and then tails, heads and then heads, heads and then, or tails and then tails, tails and then heads. Those are the different ways you could get it. Here we are going to practice using an organized list to show all the possible flavor combinations for scoop 1 and scoop 2. So how many different steps are to this action? There are 2 steps in this action, scoop 1 and scoop 2. And then how many different flavors am I choosing from? Peach, strawberry, and banana. So in my table, I'm going to have each combination of 2 scoops. For A, scoop 1 and scoop 2 can either be the same flavor or different flavors. So let's get started. I'm going to start with peach, and then peach, peach, and then strawberry, peach, and then banana. Okay, then scoop 1, let's start with strawberry as scoop 1 this time. Strawberry, peach, strawberry, 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 banana. Okay, then let's do banana for scoop 1. So banana, peach, banana, strawberry, banana, banana. This is our sample space for scoop 1 and scoop 2, and it says we can either have the same flavor or different flavors. I want you to have that organized list in your notes. Okay, now what if we said part B? Scoop 1 and scoop 2 must be different flavors. I would have to erase some of these combinations, wouldn't I? Which of these combinations would I have to get rid of for my sample space to only include different flavors? I would have to get rid of peach, peach. The board isn't writing. Peach, peach would have to go away. I'll just hover over it with my mouse. So you would cross out peach, peach, strawberry, strawberry, banana, banana. Those would have to go because we only can have combinations of different flavors. That is if this is what we're supposed to have in our sample space. So that's an organized list. Okay? All right, next, bagels. I feel like we get the point of the organized list. Do we need to do another one? We'll do another one. No, we'll not. If you have a question about an organized list, you can just ask me later. We're going to move on. Okay, next, a table. You can use a table to display the sample space of a 2-step action. Again, you're doing step 1 of the action up here, all the possible outcomes. step 2 of the action down here, and then you do all the combinations together. So we're about to do a table together. You need to do this in your notes. We'll just do one. Okay. On a scavenger hunt, a clue leads you to a locker with a note on it. Use the table to show all possible combinations of the lock. How many combinations are possible? So, we see that the combination options are, for X, it's going to be 7, 8, or 9. For Y, it's going to be 0, 1, 2, 3, 4. Okay? So on the top, I'm going to list 7, 8, and 9. Then going down the side, I'm going to put 0, 1, 2, 3, 4. Go ahead, and if you need to hit pause, it's fine. Set up your little table so that it matches mine, and then we're going to go through and do all the different combinations. Okay? So now we're going to do 7, 0, 8, 0, 9, 0. We're going to do 7, 1, 9, 8, 1, 2, 7, 2, 8, 2, 9, 2. So do you see how we're listing just all the different possible combinations? And this is our sample space because it gives every single possible outcome. Math Word could please do something that would be super. Let's try again. It should say 8, 3, 9, 3, 7, 4, 8, 4, 9, 4. Okay, so this is our sample space. We have listed all the possible combinations in a table. And you do need that in your notes. Okay, one more example of a table. This one should be pretty quick and easy. We have sweaters. We have different styles. We have V-neck, crew neck, and cardigan. We have colors blue, gray, or red. So I'm going to make a table where I have V-neck, crew neck, and then cardigan. And then I'm going to do blue, gray, or red. Okay? So now we're just going to go through, yes, do this in your notes with me, and we're going to do all the combinations. V-neck blue, V-neck green. Hello. There we go. V-neck red, crew neck blue, crew neck green. Usually G is for green, but not this time. Crew neck red, cardigan blue, cardigan gray, cardigan red. And look at all of our possible outcomes in that organized table. How many outcomes do I have? I have 9 possible combinations. Okay, last, tree diagrams. Let's knock this out real quick. Step 1 of the action, step 2 of the action, step 3 of the action. So that's what each of the kind of phases of the tree diagram is coming from. Each decision you make is a step. We make that as a part of the tree diagram. Here we go. Okay, do this with me in your notes. We are going to get 3 different children, and we want to put all the different gender combinations. So child 1 can either be a boy or a girl. Child 2 can either be a boy or a girl. So we have that branched off of the option for child 1, or boy or girl. Then child 3. Hello. Child 3. Boy, girl, boy, girl, boy, girl, boy, girl. And girl, girl, boy. And then last is girl, girl, girl. Those are all the different possible combinations of 3 children's genders. Okay, last thing we're going to do, this is the last one, a tree diagram. Do this with me in your notes. And we are choosing all the possible arrangements of 6th, 7th, and 8th graders sharing a seat. So we're going to have seat 1 and then seat 2. And then we're going to put all the different combinations. Okay, for seat 1, I could have a 6th grader, I could have a 7th grader, or I could have an 8th grader. Right? Agree? And then in seat 2, I could have a 6th grader, 7th grader, or 8th grader. In seat 2 here, I could have a 6th grader, 7th grader, 8th grader. In seat 2 here, I could have a 6th grader, 7th grader, 8th grader. So out to the side, I could say 6, 6, 6, 7, 6, 8, 7, 6, 7, 7, 7, 8, 8, 6, 8, 7, 8, 8. And there you go. All your possible outcomes brought to you by a tree diagram. Super exciting. Okay, at this point you should be ready to start on the digits for this. Compound events is 18.1. Sample space of compound events is 18.2. And then you can work on the IXLs.